Hi everyone, welcome to Python Osmosis, episode 45, the screencast that knows there are 10 types of people in this world, those who understand binary and those who do not. I'm Ryan Shane, and in this episode we'll be talking about the standard library working with binary data, record layouts. Struct is a module for dealing with binary data. That's zeros and ones. That's stuff that's not text. And there's all kinds of files that are binary data, from your Word documents to zip files to whatever. In this case, we're going to be talking about pulling out some of the header information from a zip file. So I have a zip file that I created right here of those JPEGs, which aren't really JPEGs, they're actually empty files, myfile.zip. So we're going to create something that can read that header, and it's actually just going to read the binary data, the zeros and ones on the disk. So data equals, we're going to open up that file. Open myfile.zip. We're going to open it in RB mode. That's binary read-only mode. And we're going to use the read method on that to pull in all of the bytes. Just pull them all in to data, into that buffer. Okay, so we have a counter called start, and that's going to start out at 0 for I in range 3, 0, 1, 2. So it's just going to, this is a fixed loop of, just three iterations. Plus equals 14. So jump in 14 on that counter, start. So now I am at 14. Here's where the magic happens. Fields equals struct.unpack. So it's going to pull into these fields the binary data in our structure here. So what this is a formatting string, kind of like a binary formatting string. I, H, H. Okay, I'm telling that this is what I want you to expect. And what that means is standard size, little endian byte order. H and I are 4-byte unsigned numbers. I'm sorry, 2 and 4-byte unsigned numbers. So H would be basically a short, and I would be an integer, if you're familiar with C. So unpack using that byte string data, and I'm going to do a slice here, because remember I pulled in all of the data in my read here. So start, that's the byte that I'm at, 14, so the 14th byte in, up until start plus 16. So I only need to read in 16 bytes. And then close that off. So now I have fields. And I'm going to do a little tuple unpacking, CRC32, comp size, uncomp size, the compressed and uncompressed size. Extra size. I think we're going to get some funny numbers here since these are all empty files. We're going to see some interesting things. Okay, so I'm going to unpack fields into these variables. All right. Then I'm going to jump forward 16 bytes. My counter, at least, is going to jump forward 16 bytes. Okay, the file name is data, again, is my actual binary data here at the start, which, remember, start is now 16 bytes further, plus file name size. I got the file name size from the first header up here, from my first unpack. So if you note, fields, when I do my tuple unpacking, 1, 2, 3, 4, 5, and then this was 1, 2, 3, 4, 5 things that I pulled out of here. So it was a integer, 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 short. So 4 byte, 4 byte, 4 byte, 2 byte, 2 byte. And okay. So now I have my file name. Now I want you to jump forward the file name size in my start counter. Extra. So extra is the new start plus extra underscore size, which I got from the first unpack. And here we go. Let's see what this looks like. File name, hex CRC32. We're going to force that into looking like a hex. Comp size. And let's see what actually happened. And then start plus equals extra size plus comp size. So that's going to skip to the next header in this loop. So I'm going to loop through 3 times doing this. So let's see what happens. I'm excited. And it actually worked. I was able to extract the file name. I was able to get out of here the hex of the CRC32. This is kind of interesting because this is my compressed and uncompressed size. Since these were empty files, they didn't really get too much from the compression. And that's about it for our little binary header reader. That's all for now. This screencast is directly inspired by the official Python tutorial by Guido van Rossum at python.org.